I'm going to go out on a limb here. I figure you're an open crowd. I'm already in a onesie. So, here it is. I'm a little worried, actually, that we've been approaching front-end development incorrectly, right? And I'm worried we will continue to do this unless we embrace laws and theories that govern our field. Front-end web development is a system. Web in general is a system. In the most basic sense, a system is merely a connection of pieces that come together to form a whole. So because web is a system, we're governed by the theories of systems design and systems thinking. So as engineers, we know the best way to solve a large problem is to break it down into smaller problems, and we keep breaking down these smaller problems, and each problem becomes composed into even tinier pieces until after enough iterations, we have a problem that can be solved on its own. Sort of like a discrete function, right? And after all this decomposition of our problem, what we're left with are these small, tiny components. And deciding what these components are, how they fit together, and how they relate, that's the activity of systems design. But you already knew that, right? You're like, in a onesie, come on, we're ahead of you here. So most of us know that we have to stop coding and designing page by page. We're done throwing multi-layer PSD mockups over the wall, right? Like we're doing this, right? We know we should think in terms of components and modules, that we should aim for reusability, standardization, reducing variation, and really striving to maintain like an overall pattern language. Building standards and pattern libraries because we recognize the immense value these tools and processes and models bring to our projects. And at the same time, we're working iteratively, we're employing these agile methodologies and practices, and we're prioritizing our users throughout the entire process. So it would appear as an industry that we're really on track, which is great, right? We're actually prioritizing new processes that exhibit and adhere to systems thinking and design. So what's the problem, right? So you're asking me. Here's the thing. We're doing so not because we've actually recognized and applied theory, rather because we were driven to do so. We were practically cornered. Our old processes were not working with the new constraints of this multi-device world, which honestly feels like not caring that we have to. We don't care about site performance until phones came along and dominated the market, and we realized that we couldn't continue to send these bloated pages. We didn't really care about performance standardized designs until we were forced to design responsively. And suddenly, scalability and maintenance became these top priorities in our projects. Test. Yes? OK. Remember all those terrible hacks we'd perform for gradients and drop shadows and rounded corners? Back when it was actually like the most difficult to do these things, our PSDs would be full of this like terrible, bloated design. And now, when we actually have native browser adoption, we avoid them like the plague. So I'm not here to whine and complain. I'm really happy that we're actually exhibiting so much care and concern. I'm thrilled that we're able to veer course, no matter how late or when in the process this is actually happening. It doesn't matter when we notice things that are wrong or ill-fitting. What matters is that we address them. But here's the thing. If we're only going to do things because we're forced to do them, then we will never solve our most pressing problems. And personally, I don't think this laissez-faire approach is sustainable. It means that we are waiting for triggers instead of being aware and questioning and challenging ourselves at all times. It means that we're passive instead of active, right? That's a shame, because we here are some of the best problem solvers. So if we have a better understanding of systems theory and design, we will be able to stay ahead without relying on tools and changes in our external environment to drive change and make us care. So let's dig into them. The principles of systems thinking actually go really far back, as far as Aristotle and the Ionian philosophers, who in the 6th century BC were the ones that started to see the world as orderly, hence intelligible, and ultimately that meant that it could be controlled. But the theory of systems, which is fondly known as general systems theory, or GST, is attributed to this man, Herr Ludwig, a developmental biologist, a philosopher, a poet, and actually a playwright, who in the mid-50s and 60s began to question the Newtonian simplistic views that were used to describe and understand science, and really they were just applied to the world around us. So up until then, science had always tried to explain observable phenomenon by reducing it to the interplay of an elementary unit. Each one was investigated independently, sort of acting like a one-way causality. This Newtonian simplicity, or what is often called reductionism, is central to many sciences. It's mostly central to the hard sciences. I'm not a big fan of that term. But things like physics, biology, and chemistry, where we see systems like atoms, and then 2 atoms become molecules and macromolecules and so forth, right? The problem with this approach is that it's incredibly too simple. It actually completely fails to understand the whole in relation to its parts. All it's doing is reducing parts from the whole, right? So while reductionism can be this really good mental exercise for beginning to understand how to break things apart, it really does not solve our problems, because it's actually failing to deal with properties of organization, and thus it's limiting our understanding of the complexity of the entire system. The individual pieces, although we understand them, are really disconnected. We're not viewing them as a whole. And I ran into this problem about a year ago in January with the team I work with called Oddbird. I was tasked to build this pattern library from existing code. And about that time, that's when Brad Frost released the pattern lab, which is kind of a system and kind of a reductionist system at the same time. So in my documentation, I was actually like, this pattern library and style guide is based on the theories and principles of reductionism, because I was like, this is exactly, it makes perfect sense. Distill the little pieces, and then a component is made up of them. And so I went about this. And what was the end result? The end result was just a complete mess that we couldn't understand. We couldn't really see the connections between pieces. We'd broken things down to such a small point that it really didn't help us organize patterns. And everyone on the team was confused. So that doesn't work, right? So what does Ludwig say? He basically says there has to be another way. This can't just be it. There must be a higher theory or order that's dealing with common patterns and behaviors across properties that we, the observer, can analyze and use to develop greater insight into creating these, develop better insight into the behavior of complex phenomenon. So general systems theory is really a science of wholeness, one that takes a holistic view, recognizing the inevitable interaction between a system and its embedding environment. So it's an approach to problem solving where problems are understood as part of the system instead of reacting to specific outcomes or events. And this helps us avoid unintended consequences, right? This, to me, is one of the main reasons why we need to embrace systems thinking, to avoid unintended consequences. And granted, we do a good job of cleaning up after ourselves, but if we can anticipate them, we're going to do even better. And a telling example of this, for me is our inability to let go of this idea of best practice, right? What does that really mean, actually, in a system? You can't have a best practice in a system because that's ignoring that the system could change and that practice can change. So I really don't need to enumerate this because some phenomenal people have actually given talks on this. One of them is here. And I highly encourage you to watch them and chat with them. And these people that are thinking this way are the systems thinker of our time. So pick their brains, right? So what else is unique about systems? Another key property is that they are actually self-regulating through feedback. So we can see this in our field as well. We get feedback that we should not send 2 megabytes of images to someone's phone because they can't use it and they get angry at us, and we correct course. This also supports the notion that best practices are a farce. If there's feedback that it doesn't work, if it's not working, let it go. The system is trying to correct itself. And we practice this also in our development methodologies, such as agile or iterative development. We can also see this in terms of refactoring our code. That's a type of feedback. Retrospectives give us feedback on what we're doing. And listening, of course, to our users. General systems theory also gives us principles of organization and structure. And these are actually missing in the Newtonian simplistic view of the world. And this was one of the big reasons that Ludwig was like, I don't think this can apply because human beings actually exhibit organization and structure. So we can't reduce ourselves down to one thing. Okay, so as we can see, our field and our practices are very much aligned to the underlying models of general systems processes. But as far as I can see, we're actually not talking about it in terms of system thinking or systems design or systems architecture. You can actually run a search on our popular web magazine that we love so dear, a list apart for the term like systems thinking or systems design or systems theory. And not a single article will mention this underlying principle that governs our field. Granted, we are recognizing that we are building things in systems and components, so the terms will come up. But we've never really talked about this law. So why is this? The first is that, honestly, there are very few classes for this field. And if it's actually taught, it's kind of sequestered away into fields of engineering or operations management or business. It's not really offered as a general course. At least in the US, they'd rather that you take phys ed to graduate instead of perhaps understand one of the most important theories that really kind of governs most of our existence, right? Secondly, if it's not taught, then it's not readily accessible via traditional avenues of education, then how are we going to find it in our field, which is this hodgepodge of misfits? Many of us end up here without formal education in web development. We're self-taught, or we're dropouts, or polymaths. I mean, we'll do what we want here. And I actually think this is awesome. The diversity of our field is a great thing. It means that we have more perspectives. It means that we have a potential of understanding different pieces of the system from ways that we might not see. The next reason is that systems design and theory is actually really hard to teach. So even if you're lucky to get a class, it's one of these practices that's best learned by doing, which I feel is a lot of our field, right? We need to sit down and practice. And it's great when we have mentors and we can work on teams with people that are exhibiting these thought processes. So if we have to learn on the job, that means that our jobs actually must prioritize systems design, which they don't. Most of them. Some of them do. We're getting better. But it's hard because it takes a lot of time. And there are always these constraints that we have to meet. We have to have this feature. It has to ship, right? Systems design takes really hard thinking. It also takes long discussions with other engineers and stakeholders and team members. It is incredibly collaborative. It requires an environment that prioritizes failure and experimentation. It requires team members that recognize that if you start an idea and you spend 2 to 3 weeks on it, and then all of a sudden you realize that this isn't going to work, that isn't wasted time, that's actually incredibly important to your process and should not be ignored. So sadly, management and anyone above us, they don't recognize this. Unless, again, you're lucky to work at a company that does. They want to see visible progress. They want to see those PSD comps. They want to see you committing code. They don't want to see you thinking. They don't have value for false starts and experiments. Lastly, these types of problems that we're solving are actually really hard. Complexity is used to characterize something with many parts, and these parts interact in multiple ways. It's difficult. Complicated is hard, but solvable. Complex, you might not solve something that's complex. At best, you might come up with a solution that works for that moment, realizing that you probably have to adapt and change it down the line. Our relationship with our environment is actually one of the most complex sets of interdependent connections. And if we think about front-end development, those of us that are actually tasked with understanding not only the user, but also the business requirements, and being able to translate these performant, usable designs to many, oh, no wonder this field is so hard. So how can we strive to apply more of these tenets of systems theory and thinking and design to our work? I've already touched on some of the methods we are using, like style guides and pattern libraries, and these are a wonderful start. But what other processes are available? So I'm going to take a look at some additional tools and ideas that have helped me and the teams that I've been working on be more systematic in terms of thought and design and process. There are many models to pull from, and the more choices we have, the better. So this is by no means an exhaustive list, but the exercises have yielded more sound systems. At least I feel we've been doing better. So the first, you must define your system. These are the visions, the requirements, the goals of whatever you're building. Think of this as that enclosing membrane. Every time that you make a decision, it must be bounced off of your vision. Is it meeting our goal? Do we need this? Is this going to help us achieve what we want to do? So the way that we start out is we actually have 2 documents, a bunch of questions that we sit down and go through with our stakeholders. And they can include things like, give us 2 sentences as to what you see, what's the vision for this app? What 5 features do you think will help you achieve this? We ask them about their weaknesses. How do they feel as a company? What are their weaknesses? Who are their competitors? Get them to really dig in and understand. From there, we take the vision, what they want to achieve, requirements, which can include things like, this site has to be accessible, or this site is going to be translated into 9 different languages. And we start to collate this into stories. And in working on many teams, I found that the best stories put us, the developer, in the position of the actor. Instead of defining features like, build the user review component. We want to try things like, as a user, I want to leave reviews. Now we can think about this. If a user wants to leave reviews, how do they do that? What fields does the user need to leave reviews? This type of framing of our tasks and features sets us up for the next phase. It gets us to ask questions immediately, instead of build the user review component. Okay, I guess I'll start with what's attached in the design, right? So this next phase, after we've got our stories, now we need to figure out how this content lays out on our site. And this can get called many things, and we often have many fancy names for people that work on this section, like information architect or content strategist, or all these names that are, in my opinion, just a pure distraction and creating silos. Does not matter. Put every smart person on your team at this point, because this is the hard part. This is the part where you're dealing with a lot of ambiguity, and you have to trust that at the end of it, there's a path. There's a structure to your application that you understand the ins and out of. So we start with sitemaps. And we try to do as much of our work actually in browser. And we use a tool called CSSConf. And there's a Compass extension if you run Sass. We've switched over to libsass recently, and it's quite interesting. We've been working on a libsass compatible release, but you know, priorities. But maybe one of you will do it. So CSS Slick Maps lets you create clickable sitemaps. And when you start, you might not know everything. Let's say we have a site we know we want user profiles. We know we want users to leave ratings, so there'll be a rating page. We'll start out by just putting everything at the top level and not really worrying and trusting that we're able to come back and correctly group things by the best taxonomy. The next most important piece that is something that I've started working with since joining Oddbird about 1.5 years ago. And honestly, in the 10 years that I've done web development, this is probably the first time where I've worked with a team that prioritizes content templates and has taught me the immense value of working with them. There's a wonderful article by Aaron Krizane on A List Apart that explains content templates. But in short, this content template defines what's going on your page. It starts with a brief description, the goals of what you want to achieve, and it can get very detailed. You can be specific and say, I'm going to have one paragraph that's no longer than 250 words followed by 3 bullet points on the product review page. That's incredibly helpful. But what your goal is here is to define the pieces of content that go on the page. You want to get to the fields. What's the information that the user is going to see? And then you want to fill that in with actual content. None of this lorem ipsum stuff, because that doesn't help us, right? So this process really ensures that we're actually meeting the requirements and the visions, that we're addressing the whole. And what ends up happening when we're working on this is that sometimes things will come up and we're like, oh, wait a minute, that's not in any of our vision documents. That's not in our requirements. Is this necessary? If it is, then we need to go back and amend that. And it's this constant back and forth, this constant ability of being able to understand the piece that you're working on, but never forget the whole. Lastly, sketches and prototypes. Once you have an understanding of what content you want and an example of the content in your content templates, you can start sketching that out. So let's say we define our user review component to have 3 fields. It's got the user's name, their avatar, and a description of their review. Now your designer or your user experience designer or whomever on your team is responsible for sketches and prototyping can take those 3 fields and begin to think of how they should come together. Eric Suzanne, my colleague, uses the simple paper app on his iPad to just do rough sketches. And either he'll implement them in HTML or I'll throw them into HTML as soon as we feel like we've got something, and then we continue to iterate from there. The next thing that I find really helps us in our processes is to use the most robust tools that we can. When the web started, CSS and HTML as they are, as these flat languages, were the most robust tools that we had. So we used them. And it's fine if you still want to use them. But we have even better tools. And it's fun to use those tools because they let us architect. They let us do a better job of really componentizing and modularizing our code and keep us in this systems thinking mindset. So instead of HTML, look for a robust templating language. If you work in Rails, start investigating into helpers and decorators and partials and creating your components into these reusable objects. I work at a Python shop. We use Jinja, which has a node variant called Nunjux. I love it. It lets us create macros, which in my mind are just these reusable pieces of code that we can pass arguments to and generate full blocks of HTML. And there's handlebars and mustache and a bunch of others. So spend some time. Don't just pick Haml, or don't just pick what someone gives you. Think about it. It's a tool. Same for CSS. Preprocessors, post-processors, whatever your flavor, better than writing plain CSS at this point. Guidelines, documentation, and standards. Probably one of the easiest ways to tell whether or not the system was actually designed with something in mind. A project without documentation, I'm questioning whether or not you really thought about it as a whole. You shouldn't have to read through your code and guess what's going on. If I read through your code, things should be well documented. I shouldn't have to ask you. Self-explanatory. And there's a bunch of different methodologies, and people have done a wonderful job of putting a lot of information out there. There's CSS guidelines that we heard of from Harry. There's Sass guidelines that Hugo's been working on. There are code standards. GitHub's most recent style guide actually has an entire section on coding standards. These are things that you want, right? These set a tone for your system and ensure that anyone can come in and work on it. I cannot stress the importance of communication in getting our work done. We need to talk, we need to iterate, and then we need to keep doing this. Take your headphones off, ask your team member, prod them. Don't be afraid. So whether or not you agree or disagree with me that this perceived lack of systems knowledge is leading us a wee askew, I hope that we can at least agree that systems thinking and design is something that we as an industry should understand, right? It's a fundamental view of the world that says that when we build and design and make decisions about something, we can't do it in isolation. We have to be aware of the world around it and within it. And this really ensures that things become more coherent, more whole, and ultimately ensures that we're respecting the web of nature. So my name is Claudina Sarahe, and I organize and speak and work. I run a similar well, not a similar conference, but I run a conference called CSSConf, and I organize a monthly meetup in New York. I work with a rad team of brothers and a designer in Denver called Oddbird, and I also consult independently with teams where I help them design systems and processes. And sometimes I'm a penguin. If you are interested, I urge you to please submit to the CSSConf CFP. It is open. Just because it has Sass in the title does not mean that we only accept things with Sass. It's a conference for front-end web development and really just celebrating the Sass community and our love of the preprocessor. And we totally welcome talks that are perhaps about post-CSS or other things. How else are we supposed to learn? So thank you so much.